स्क्रीन नजर आ रही है?
जी सर, आ रही है सर। गुड मॉर्निंग सर।
मॉर्निंग मॉर्निंग। ठीक है भाई, फिर शुरू करते हैं। So let us start with network layer or IP layer. TCP IP mod TCP IP. IP is network layer protocol. So let us see that network layer protocol. We'll be seeing two things: addressing which is IP address, and then routing. We've seen that in that network layer, we are calling this address as logical address. At MAC layer, we are calling address at physical address. At transport layer, that address is port number. And if you say at application layer, then you know the name, the domain name of your site. If you are using mail, then the domain name included with the name of the user. So those are addresses in application layer. Okay. And as I told always that whenever there is a possibility that when you are trying to send the packet and that can be received by multiple receivers, then you need address so that a particular receiver can be identified through that address. Network layer will be seeing what is IP address. This lecture will be concentrating on IP address first. Routing, it's to find path from source to destination, and then forwarding the packet over this path so that the packet can reach to the destination. So let us first take the IP address, should understand the IP address, and then we'll go to the routing. But please remember that routing and IP address both are interlinked. The design of different fields inside the IP address is in such a way so that it helps in routing the packet to the destination. Okay. So let us start with the IP address. In IP address, it is it's a 32-bit identifier. The 32-bit, that's the IP version 4. And nowadays, 128-bit IP address is there, which is IP version 6. So we'll be concentrating on this IPv4, and maybe in last lecture probably I would try to tell you in brief about IPv6, because the course do not allow me to elaborate. Basic fundamental remains same. There are certain things which has been included in IPv6. Otherwise, most of the things are basically same. And still IPv4, the user base is quite large compared to IPv6. Although in future, sometime in future, we need to shift at IPv6, all of us. Okay. So let us start with IPv4, which is, if you ask what was about IPv5, so I do not know much about IPv5. It was a standard which never became the standard. Actually, IPv5 was somewhere related to OSI reference model, but they never kicked. Okay, so let us come to IPv4, which is a 32-bit number, 32-bit number, and it's written something like this: 202.141.55.6. I generally call it a point or dot. It's not a decimal actually. This point. It is just, these are 8 bits and a decimal number of 8 bit. And the second field, so there are 4 fields. Each field is of 8 bit. So this is 8 bit. Then next 8 bit. And obviously these are decimal value of 8 bits. So the one which I have written. Okay. So let us see what are different fields in IP address. Let us first see that. Before I go into detail of IP address in 32-bit, let me try to tell you the different fields in IP address and why that those different fields. The basic idea is that इसका ये बार-बार इधर-उधर हो जाता है, forget किधर चला गया. Basic idea is that we have a bigger block. Within bigger block, we have some smaller blocks. And within the smaller blocks, you can have some number of nodes, something like this. Okay. So the IP address, some field of IP address, it should be okay. Some field of IP address mapped to the bigger block. Then some other field of the IP address try to map to the smaller blocks, and then some field of IP address try to map on further smaller elements inside that block. Okay. This basic idea, as you know, whenever is why we are trying to divide the IP address into different fields and which are mapping to different blocks. If you say this is the left hand side is the MSB, most significant bit, and the right hand side is the LSB, the significant bit. So because whenever you are trying to map, the bigger block address is towards MSB and the smaller block address is towards LSB, and that's very natural because MSB change in the bits when we are writing different numbers in a block. So LSB changed faster than MSB, and that's the reason why these fields are kept in this fashion. Okay, and this is a very natural in any address when you are writing an address, something like say Rajesh, room number 44, Hostel Tilak, my man in IT, Allahabad, UP, India. So what we are doing? This is a bigger block, India. Then within India, UP is a smaller one, and within UP, Allahabad is a smaller one. And then within Allahabad, MNIT is a smaller one. Okay, so it's a hierarchy of bigger blocks, then smaller, and then obviously MNIT contains different hostels. So, right. So the same, if you consider this address contains different field, and the bigger block, then a smaller block, then a smaller block. And why we are keeping this? Because whenever we need to deliver a packet, the post office, which is involved in delivering the packet, it initially find okay whether the packet is inside the country or outside the country. So the biggest block. And then within the country, which is state. So it try to forward the packet based on the state. Once it reaches to that particular state, within that state, it try to think of the district, what district is, right? So when it is trying to route the packet, we are somehow inside the address trying to put the information so that in routing the packet, in sending the packet, it can be forwarded using bigger blocks than smaller, the hierarchy of that. Similarly, in IP address, we have bigger block, then a smaller block, then a smaller block. Okay, and that helps in routing the packet. Okay, so that's why I said that addressing and routing, they are interlinked. Routing, कहीं आपको pronounce होगा routing, ROOTING, routing, and somewhere you can pronounce routing. So both are maybe there. So while trying to route the packet, these addresses are used. We also know that in your mobile number, how we used to write the mobile number, 91 9415 649167. So this is a bigger block which is towards MSB side, and that denotes the country. And I think it's the smaller block, this portion, which probably is denoting the subscriber, which particular not subscriber, which particular company is providing, whether it is the BSNL or AHL or Reliance or whatever it is. And then within that company, this portion, although that I do not remember whether this, what I'm trying to tell about the phone number exactly matches, but perhaps those are the fields which are trying to identify, and this one is probably the subscriber within that company. Okay, so you can have that within, if this denotes 9951, and that denote the same number 949167. So obviously these two are different because of this portion. Okay, so within there can be same number inside two different blocks, right? So this and that is the basic idea. Now let me show you this idea through an example. And before I go to 32-bit IP number, let us take 8-bit number. 8-bit number. Let us take 8-bit number in the example, and let me show you different parts of the IP address in 8-bit number. If you can understand that basic concept, and then we'll be scaling it to 32-bit and the actual IP address, how different things are there. So let me take an example and try to explain how different fields inside a 8-bit number are mapped to different blocks. First, let us see that, and then I would be trying to relate it to the routing, maybe later on, or somewhere during this lecture also in brief. So suppose चलिए थोड़ा इसको नीचे कर लें, यहाँ पे लेफ्ट पे चले जाते हैं, यहाँ पे आएगा नहीं, अगला पेज ले लेते हैं. So suppose we have 8-bit number. So how many different combinations can be there? 2 to the power 8, 256, everybody knows that, right? So there can be different 256 addresses from 0 to 255. These 256 addresses can be there. Now suppose inside our institute, we have 4 blocks. Hostel, college main building, computer center, and colony. Now if we have to allocate 10 nodes in hostel and main building, there are 10 nodes. In computer center, there are 10 nodes. And in colony, there are 10 nodes. Right. So every block contains 10 nodes. Now we have to allocate addresses which are from 0 to 255. Okay, if we consider that will be 0, we are not going to allocate to anybody, suppose. So we are starting from 1 and allocating the address. So for hostel, we are allocating from 1 to 10. If we do the allocation in serial manner, right? For main building from 11 to 20. For computer center from 21 to 30. And for colony from 31 to 40. And later on, we need to add 5 more nodes in each block. Right. So now suppose we have added 5 more nodes. So in the hostel, I have said that, okay, from 41 up to 45. ठीक है. 45. Main building 46 to 50. Computer center 51 to 55. And colony 56 to 60. If we are doing the allocation like in this serial manner. So if we need to locate an address, say 52. So what is the binary value of 52? कितना होगा? 0, 2, 0, 52 का फिर एक लगाए तो आ गया आपका 32, फिर एक और लगाया तो आ गया 16, 48, then 58 के बाद फिर 0, 4 और करने इसको है ना, 1 और 1, 1, 2, 3, 4, 5, 6, 7, 8. This is the value of 52. Okay. So if we need to search a node which is having address 52, so out of this list, by looking over the address, there is no field which can tell to us that if you look some field of these 8 bits, some bits which can tell that, okay, this address belongs to computer center. No. We need to search linearly, go on matching with every address to find out where this address belongs to. We need to go to the hostel, find out, okay, whether this address belongs to, then need to go to the main building and need to match. Okay, so when we try to send a packet which contains the address 52, as I said, please, whenever we are trying to assign addresses to the nodes, to the computers. Okay, I'm saying node because sometimes आपका end desktop भी हो सकता है और कुछ बीच के router भी हो सकते हैं which are having the address. So that's why I'm saying node. कभी computer भी बोल सकता हूँ कहीं पे, doesn't matter. No interchangeable. So as I said, that final thing is key when you are trying to deliver the packet, then only the address is relevant. Otherwise, address का क्या मतलब है? ठीक है. So if an address contains destination address 52, if a packet contains destination address 52, so now here we need to search linearly, and obviously, if you have a small list, then fine. But you have a large number of nodes which are there over the internet, and then you need to search and take a lot of time to search a particular address, a particular node over the internet. Okay, so obviously, instead of keeping in this way, the other method which is used is that, okay, let us divide. We can have some other different ways to do that. One way is that, okay, we divide, we have total 256 addresses. We have a total, ये कहाँ चला जाता है इसका? We have total 256 addresses, and there are 4 blocks. So if we divide it by 4, so every block will have 64 addresses. Right? If we do division in this manner, so now let us do the allocation of 64 addresses in continuation. So in one block, we'll be allocating 64 addresses, and next block, another 64 addresses, the next 64 addresses. Okay, let us do that and try to see whether now some part of the bits can denote the block or not. Okay, that is the same idea as I said that inside the phone you have or different blocks. So for the hostel, we have the allocation. What allocation? 0 to 63. So these bits will be what? 0, 0. And up to last one will be 63 will be 0, 0, 1, 1. Okay. Then to main building, college main building is 64 to 127. Okay, so 64 is your 0, 1, 0, 0, 0, 0, 0, and that will go up to 127, which is 1, 1, 1, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then we have computer center 128. कहाँ तक गया ये? 64 ऐड कर दीजिए 128 में 91. So this is 1, 0, 1, 2, 3, 4, 5, 6, and we'll go up to 0 and all 1. 1, 2, 3, 4, 5, 6. And then colony, which is going to be from 192 to 255, which is 1, 1, and then 1, 2, 3, 4, 5, 6, up to 1, 1, 1, 2, 3, 4, 5, 6. Okay. So these are addresses. Now if you look, over these addresses, if I write somewhere the address number, say and so the first address which we have written, if you see the first 2 bits, If you see the first two bits, by looking over the first two bits, you can say that this address belongs to computer center. Because if you see the first two bits of the starting address of computer center and first two bits of the last address of the computer center, the first two bits remain same. So any address out of these 256 address which contains first two bits as 10, that belongs to computer center. Okay. So this is third address. The value, if you forget about 10, so this is the third address of computer center. या आप कहेंगे फोर्थ है, फोर्थ कह लीजिए 128 को कंसीडर करेंगे तो फोर्थ एड्रेस कह लीजिए. इफ यू कंसीडर कि 128 बात को हम लोग बात करेंगे कि 128 को we do not assign to the node. ओके, सो जो एड्रेसेस नोड को असाइन है वो 129 होगा, 130 होगा, 131 होगा. So in that sense this is the third address or third node inside computer center. Okay. And if you look over the second address, which is having 10 in the first two bits, and 10 उल्टा लिख दिया यार, दूसरे वाले में 01 कर लो उसको, गलत लिख दिया भाई. एक मिनट, रबड़ कहाँ है, ये गलत लिखा है ना ये. हाँ, सेकेंड एड्रेस और थर्ड एड्रेस, सेकेंड और फर्स्ट तो एक ही लिख दिया था ना, इसको चेंज करो. सेकेंड एड्रेस we write as 01. So if you look 01 is main building. In main building, starting address contains 01 and last address also contains 01. So this means all the addresses in this block contains first two bits as 01. So any address in the packet, if it contains 01 in the first two bits, that means this address belongs to main building. Here this is third node. Now I'm saying node because first address I'm not going to use to assign to the node. That is 64, I'm not assigning to a node. Why we are not assigning will be seen later on. Okay, तो node को जो assign कर रहे हैं हम address, वो block का second address, third address, fourth address ऐसे assign कर रहे हैं. First address assign नहीं कर रहे. So I'm saying this is the third node, but third node of main building. Although this is again 3 and this value is again 3. Okay. But because they belong to different blocks, so they are different addresses. Right? And now you can think of that if we get a packet which contains an address out of these 256 addresses, right? If the packet is containing 00 and then 000011. Now looking over first two bits, we can tell that this address belongs to hostel. Because in the hostel address block, first two bits are 0. Right? So now we inside this address, we have divided the address into two fields. What two fields? These two fields. These two fields. One portion is which is denoting a bigger block. Okay, this is denoting a block, whether it is hostel or main building or computer center. If the first two bits are 0, 0, this means this is hostel. If the first two bits are 0, 1, this means it's college main building. If first two bits are 1, 0, then that means it's computer center. And if first two bits are 1, 1, that means this is colony, right? And remaining 6 bits, this remaining 6 bits, this 6 bits. ये जो पहला वाला पोर्शन था फर्स्ट 2 बिट का, this is denoting the block. Okay, this is denoting the block. And remaining 6 bits, they are denoting, if I say, the node inside the block. Inside the block. So if I have written somewhere 1, 1, 0, 0, 0, 0, 1, 1, we can say this is third node of colony. Okay. So in every block, the third node address, if you say, this address is same, but because the block is different, that's why and it is easy to identify that, okay, this particular node belongs to the node which is having an address in which first 2 bits are, if it is 1, 1, then that belongs to colony, right? So first we search a bigger block through this address and then go into finding out within that block a particular node, right? So within that block, if we have to find out a node, right, now we need to search linearly within that block, but that block we can find out easily. So instead of searching in all 256 addresses, if there are 256 nodes in all 4 blocks, instead of searching in that way, we have reduced it to a block of 64 addresses. Okay, and in the address portion, we are able to divide 2 parts. One part which is towards MSB, first 2 bits, MSB side, they are denoting a bigger block, and remaining 6 bits are denoting a node number within that block. So ये बहुत सिंपल आइडिया है, इसको और आगे बढ़ाते हैं. अगर यहाँ पे किसी को समझ में ना आया हो तो मुझे बताएं, नहीं तो फिर इसको और थोड़ा सा आगे बढ़ाते हैं आइडिया को. पहले इसको बताइए कि अगर किसी को समझ में ना आया हो, any question, if anybody is having ये field within the address or mapping of that field to the block. Okay, and I told you what the aim is, where we are trying to strike. कहाँ कोशिश कर रहे हैं हम कि field जो है bigger block को match करे. And why we are doing that? So that if we receive a packet, for us it is easy to search that address, because the bigger block is easy to find out कि ये बड़ा block है. And inside the address, there are certain fields which are telling about that block. So for us, it is easy to deliver a packet into that block, because first go to the bigger block and then go inside a smaller one, which are nodes in this case. So there are 2 portions. One is the block, the hostel and the main building, and the second one is the node inside the block. तो अगर यहाँ समझ में आ गया है तो फिर इसको थोड़ा सा और एलिब्रेट करते हैं ना, कि अब हॉस्टल को डिवाइड करते हैं। लेट अस कंसीडर कि जो हॉस्टल है उसमें मान लीजिए देयर आर 4 हॉस्टल्स, तिलक हॉस्टल, पटेल हॉस्टल, मालवीय हॉस्टल, जो बॉयज हॉस्टल है हम लोग के यहाँ, और टंडन हॉस्टल। ओके, ये 4 हॉस्टल। So now let us again do a further division and try to put some information inside the address and try to find out some portion in the address as a field to identify that whether a particular address belongs to Malviya Hostel, to Tilak Hostel, to Patel Hostel or to Tandon Hostel. तो 4 और हॉस्टल में इसको डिवाइड करते हैं। अगर कुछ दिक्कत अभी तक हो तो बताए, नहीं तो फिर इसको और फर्दर डिवाइड करते हैं। हाँ, चलिए।
हेलो।
हाँ बेटा बताओ क्या कर।
सर ऐसे डाउट था सर, जैसे अगर वो IPv4 का एड्रेस लें, लाइक 32 बिट का होता है, तो उसका अगर परमिटेशन भी करें तो आई मीन 2 to the power 32 आई मीन बिलियन ऑर्डर का होता है, तो उससे ज़्यादा डिवाइसेस होती है ना सर, तो आई मीन अगर कोई न्यू डिवाइसेस होगी तो उनके लिए यूनिक IP एड्रेस नहीं बन पाएगा ना। आई मीन डिवाइस तो बिलियन ऑर्डर से ज़्यादा ही है वर्ल्ड में।
वो कह रहे हो?
हाँ,
वो प्रॉब्लम है बेटा, तभी तो IPv6 पे गए हम लोग। वो प्रॉब्लम दूसरी है, वो प्रॉब्लम दूसरी है जो तुम बोल रहे हो कि 2 to the power 32 मैक्सिमम डिवाइसेस हो सकती हैं। और यहाँ पे अभी एक चीज मैं और बताऊंगा कि इफ यू सी हियर, अभी 2 to the power 32 छोड़ दें, 2 to the power 8 करेंगे तो अभी हम लोग के पास कितना मैक्सिमम डिवाइस हो सकती है? 256। लेकिन 256 भी यूज नहीं हो पाता अगर हम ये हायरार्की इसमें करते हैं, क्योंकि जो मैंने एलोकेट नहीं किया एक एड्रेस, स्टार्टिंग एड्रेस को मैं एलोकेट नहीं कर रहा ना नोड को, तो वो स्टार्टिंग एड्रेस हम ब्लॉक को आइडेंटिफाई करने के लिए रखते हैं। जैसे हॉस्टल का है तो वो जो 0 वाला एड्रेस है, ये जो था, अभी मैं वहीं पे आ रहा हूँ, तुम्हारी बात पे भी फिर आ रहा हूँ। पहले ये जरा सा बता दूं कि जो हॉस्टल है, तो हॉस्टल के लिए जो 0 एड्रेस है, मेन बिल्डिंग का जो ये 64 है, so we do not allocate 64 because we keep this address to identify that block itself. मेन बिल्डिंग को आइडेंटिफाई करना है तो 64 से आइडेंटिफाई करना है। This 64 is not address of any node inside the main building. Similarly, कंप्यूटर सेंटर है तो कंप्यूटर सेंटर को 128 जो फर्स्ट एड्रेस है ब्लॉक का, उससे आइडेंटिफाई करना है, और उस एड्रेस को हम किसी भी मशीन को जो कि कंप्यूटर सेंटर के अंदर है, जो नोड है, उनको एलोकेट नहीं कर रहे। ओके, सो इफ यू सी इन दिस केस 256 में से 4 एड्रेस तो हमने ब्लॉक को आइडेंटिफाई करने के लिए यूज कर लिए, सो फर्दर रिड्यूस हो गई नंबर ऑफ नोड्स जब हमने ये हायरार्की लगाई, राइट, कि 4 एड्रेसेस we are using to denote the block. This means 256 minus 4. अभी और बताऊंगा कि एक एड्रेस और है जो हम यूज नहीं करते हैं नोड को एलोकेट करने के लिए अभी बात को। तो नाउ कम टू योर पॉइंट, 2 to the power 32, और हमने अगर वो ब्लॉक्स बना दिए तो 2 to the power 32 नहीं होंगे, उनसे कम होंगे, पहली बात। ओके, देन डिवाइसेस तो ज्यादा है, दिस इज ट्रू। देखिए क्या होता है, थोड़ा सा हम लोग इसकी बात कर लें कि when TCP/IP was proposed 40 साल पहले, 40 years back, nobody thought, देखिए जो आदमी प्रपोज कर रहा है, he never thought that his scheme one day will become so popular that everybody starts demanding IP address. It was never thought at the time of the design, because TCP/IP is one model which became popular nowadays. डेकनेट था, आज शायद तुम लोग जानते भी नहीं डेकनेट को, लेकिन डेकनेट की प्रोटोकॉल थी, एप्पल की अपनी थी, लेकिन कहाँ यूज होती है? ओके, एप्पल को तो कम से कम जानते हो, तो उसकी नेटवर्किंग की भी प्रोटोकॉल थी, लेकिन वो तो यूज नहीं होती है या खास यूज नहीं होती। ठीक है, विंडोज का अपना था, बट सो at that time 32 bits were kept, considering कि यार काफी है, but later on demand increased and everybody started demanding for one IP address. Okay, और devices बढ़ती चली गई, TCP/IP implement होता चला गया, right? ज्यादा user base increase हो गया, so this is the problem, and that's why क्या हुआ कि 32 बिट नहीं हुआ, तो अब उसको कहा कि भाई 128 बिट का IPv6, ठीक है, ये IPv6 यूज करेंगे तो डिवाइसेस, क्योंकि जो 128 बिट है उसमें कुछ स्क्वायर फीट में उन्होंने कैलकुलेट किया कि इतनी डिवाइसेस आ सकती हैं, जो कि नहीं होगी होपफुली, तो 128 बिट IPv6 पे का प्रपोजल हुआ। बट अगेन सी टेक्नोलॉजी, तुम लोगों को शायद याद हो कि एक जमाने में, तुम्हें पता नहीं तुमने कभी देखा हो कि नहीं, कैसेट प्लेयर होते थे, और कैसेट प्लेयर ने पता है किसको रिप्लेस किया था? उससे पहले बड़ी बड़ी डिस्क होती थी, कभी आपने देखा होगा एक बाजा जो इंस्ट्रूमेंट रहता है बजाने वाला, बजता है जो, उसमें एक भोंपू टाइप का लगा रहता है, so that type of instrument was there which was having a bigger disc, बहुत बड़ी डिस्क होती थी, उसके ऊपर रोटेट करता था हेड, that was replaced by कैसेट प्लेयर, कैसेट ने रिप्लेस कर दिया, जिसमें एक रील होती थी। ओके, तो लेकिन क्या हुआ, टेक्नोलॉजी वापस आई डिस्क की, और डिस्क एक, आप लोगों ने शायद डिस्क तो देखी होगी, CD ROM तो देखी होगी, है ना, तो वो वापस आई और उसने कैसेट को बाहर कर दिया, तो टेक्नोलॉजी दाएं बाएं होती रहती है। तो IPv4, IPv6 was suggested, and as I'm saying, yes, in future we need to shift to IPv6, everybody has to, but still IPv4 का यूजर बेस IPv6 से बहुत ज्यादा है अभी भी। उसका रीजन ये है कि although IPv6 का प्रपोज हुई थी नियर अबाउट 27 years, 94-95 के आसपास IPv6 was proposed. Okay, so still 27 year तो हो गए, अभी भी इम्प्लीमेंट नहीं हुई है पूरी तरह से IPv6, although nowadays every operating system, every router, every machine which you are purchasing is compatible with IPv4 and IPv6 both. सारे ऑपरेटिंग सिस्टम इस वक्त जितने भी आ रहे हैं सब कंपेटेबल हैं दोनों को, ओके, बट स्टिल IPv4 का यूजर बेस IPv6 से बहुत ज्यादा है, जबकि ये प्रेडिक्ट था कि ठीक है विद इन 8-10 साल में, 5 साल में IPv6 विल टेक ओवर द IPv4। लेटर ऑन क्या हुआ, एक उसके अंदर एक टेक्नोलॉजी शुरू हुई जिसने IPv4 की डिमांड कम कर दी। एक एड्रेस होता है जिसको बोलते हैं पब्लिक एड्रेस, एक एड्रेस होता है जिसको बोलते हैं प्राइवेट एड्रेस। तो पब्लिक एड्रेस एंड प्राइवेट एड्रेस, और फिर हम लोग एक मशीन यूज करते हैं जिसको बोलते हैं नेटवर्क एड्रेस ट्रांसलेटर या प्रॉक्सी। अगर आप लोग यहाँ पे शुरू में तो जब तक रहे होंगे तो प्रॉक्सी यूज किया होगा, है ना। सो व्हाट प्रॉक्सी डू और व्हाट नेटवर्क एड्रेस ट्रांसलेटर डू कि वो पब्लिक एड्रेस की डिमांड कम कर देता है। If you have 10,000 machines inside your organization and you want to connect to the internet, right? What happens? You use 1, 2, or 3 or 4 proxies or network address translators. Okay, which says, okay, out of 10,000 machine, if you use 4 or 5 network address translators, okay, what it do, it map private IP address to the public IP address. So your demand reduced from 10,000 to say 10 or 20 or 50 IP addresses. Okay, so that netting and proxy जो यूज कर रहे हैं, जो कि हम लोग आज भी यूज कर रहे हैं, आपके घर में जितनी भी मशीन है, आप कभी भी आईपी एड्रेस देख लीजिएगा, वो अपनी मशीन पे अगर आपको आईपी एड्रेस चेक करना है, जो आपके सर्विस प्रोवाइडर ने दिया हुआ है, तो लिनक्स की मशीन हो तो इफ कॉन्फिग कमांड लगा के देख लीजिएगा, और विंडोज की है तो आईपी कॉन्फिग देख लीजिएगा. Okay, they have provided the IP address range which they have provided. केवल 3 ही IP एड्रेस होंगे जो प्राइवेट IP एड्रेस होते हैं. 10.0.0.0 एक ये है /24, then 172.16 to 31.0.0/20. ये 16 था, ऊपर वाला 8 था, सॉरी 24 नहीं 8 है, /8, and then 192.168.0.0/24. तो केवल ये 3 ही रेंज हैं जहाँ पे जो प्राइवेट आईपी एड्रेसेस हैं. एंड इफ यू चेक योर मशीन एड्रेस, जो भी या सर्विस प्रोवाइडर ने जो आपको एड्रेस दिया होगा, इसी में से कोई रेंज होगी एक आउट ऑफ 3. हम लोग जानते हैं कि अगर तुमको याद हो कि अपने यहाँ कॉलेज में जब यूज करते थे एड्रेसेस, तो ये था 172.31 वाला था जो प्रॉक्सी एड्रेस है, इधर का डालते थे हम लोग. सो दिस हैज रिड्यूस्ड द डिमांड ऑफ आईपी एड्रेस IPv4, और इससे क्या हुआ, सस्टेन हो गया बहुत दिनों तक. IPv4 बहुत दिनों तक चल रहा है इसकी वजह से. एंड प्लीज रिमेम्बर, यही एक रीजन नहीं है प्रॉक्सी और नेटवर्क एड्रेस ट्रांसलेशन को यूज करने का. क्या हुआ भाई, कौन है भाई? अपना ये बंद कर दीजिए बेटा, किसका वो है, मैं यहाँ से म्यूट कर देता हूँ सबको. अपना वो म्यूट रखा करिए माइक. चलिए ठीक है, कर दिया. ओके, सो क्या बता रहा था, IPv, ये नेटवर्क एड्रेस ट्रांसलेशन एंड प्रॉक्सी, they have reduced the demand of IPv4 addresses, for one thing. Second thing is they are used not only because they have reduced the demand, they are used for security purposes also, because any packet from outside cannot enter into your network if you are using a private IP address. Only very limited amount of nodes are exposed to the internet. Those nodes which you generally call as server, otherwise your clients are free from. So nobody can come from outside to the inside easily. So because of security reasons, IPv6 में भी net use होता है आजकल. It's not only in IPv4. The concept of netting, network address translation, वो IPv6 में भी use होता है. Because security provide करता है, default security मिल गई आपको. अगर आपने वो डिवाइस यूज कर ली एक बीच में, तो डिफॉल्ट सिक्योरिटी मिल गई. बिकॉज ऑल द पैकेट्स, ऑल द ट्रैफिक, anybody try to penetrate into your network cannot. It can only come up to that device which is network address translator, or those devices which you have your network has configured them as a server and has given the access to the rest of the world. So those servers are, yes, on public address generally, although you can put your servers also in private IP address. That's a different technique. Okay, so because of this reason demand थोड़ी कम हो गई. मतलब सस्टेन करके IPv4 बहुत सालों तक। बट यस यू आर ट्रू कि IPv4 2^32 और उससे भी कम है क्योंकि हायरार्किकल है, और आगे अरेंजमेंट देखिएगा तो 2^32 नहीं है, उससे भी कम नोड हम कनेक्ट कर सकते हैं काफी। ओके, बट यस स्टिल इट इज वर्किंग, क्योंकि इतना यूजर बेस है कि एक दिन में चेंज नहीं कर सकते आप, ये प्रैक्टिकल प्रॉब्लम है। ओके, बट यू आर ट्रू कि वो नोड ज्यादा है और एड्रेसेस कम है, एंड दिस इज ट्रू। ठीक है। बात समझ में आई?
यस सर। आई मीन
हाँ।
सर एक और पॉइंट था सर।
हम्म।
आई मीन ये ठीक है सर कि वो जो एड्रेस ट्रांसलेट हो जाते हैं, लेकिन सर जब वो डिवाइस पेयर टू पेयर कनेक्ट होते हैं ना सर, जैसे जिसमें सर्वरलेस होता है, तो
अच्छा,
उनमें कैसे कनेक्ट हो जाते हैं वो, जब आई मीन वो एड्रेस ट्रांसलेट होता
पीयर टू पीयर वाला।
है? हाँ
आ, एक दिन मयंक से कहूंगा पीयर टू पीयर भी तुम लोगों को इस आंसर को, इस क्वेश्चन का आंसर दे दे, मुझे बहुत क्लियर नहीं रहता है पीयर टू पीयर। बट एनीवे, इफ यू वांट टू गो आउटसाइड तो एक तरीका है, उसमें हम रिवर्स पंचिंग करते हैं नेटिंग में भी, तो वो पीयर टू पीयर भी उस तरह से एक्सेस हो सकता है, लेकिन कितना ट्रूली एक्सेस हो जाता है मैं मयंक से बात करके बताऊंगा तुम लोगों को। है जो पीयर टू पीयर वाली प्रॉब्लम तुमने बताई, सर्वर वाली देखो मैंने बताई तुमको, और सर्वर में भी मैंने बोला कि स्टिल यू कैन डू रिवर्स मैपिंग, एक होती है उसमें, तो वहां से आप सर्वर को भी प्राइवेट एड्रेस में रख सकते हैं। तो और पीयर टू पीयर वाली मैपिंग में भी अगर आप ठीक से पंचिंग करें नेट की, देन यू प्रॉब्ली कैन डू दैट, बट कंफर्म मेरा बहुत नहीं है ये आंसर। मयंक से और बात करूंगा, और हो सकता है मयंक को ही कहूँ कि इसको थोड़ा तुम लोग क्लियर कर दे इस आंसर को। ठीक है।
ओके।
हाँ, बट होता है उसमें भी, उस तरह से होता है। तो ये था। अब मैंने कहा था कि क्या करना है मुझे, हाँ इसको अब हम फर्दर एक्सटेंड करते हैं कि हॉस्टल को हम और 4 ब्लॉक्स में डिवाइड करते हैं कि टंडन हॉस्टल है हमारा, पटेल हॉस्टल है, तिलक हॉस्टल है, एंड मालवीय हॉस्टल। ओके, जो बॉयज वाले हॉस्टल। तो लेट अस डिवाइड दैट एंड सी। तो इसके लिए अभी 5 मिनट का गैप कर लेते हैं, फिर करते हैं। 5 मिनट गैप कर लेते हैं, फिर शुरू करते हैं। Okay, so let us now see as I said that if we have 4 hostels, so they are Tilak Hostel, Tandon Hostel, Malviya Hostel, and Patel Hostel. In hostel, we have total 64 addresses. Okay. Right. Now, if we want to place in every hostel in Tandon, Tilak, Malviya, and Patel hostel, say 3 nodes in each one. Okay. So this 64 addresses in those 4 hostels can again be divided into 64 by 4. That means 16 addresses. So out of 16 addresses, there are 3 nodes connected in each hostel. So 3 addresses can be used. Rest are left empty and they belong to in that hostel. So Tilak hostel, the will be from 0 to 15, right? And that number is going to be what? 0, 0, then 0, 0, 15, then 1, 1, 1, 1, right? And then 16 to 31. Suppose we have allocated to Tandon hostel, because you can allocate 16 addresses out of 64. So 16 to 31, that means 0, 0, and then 16 करना है 1, and then sorry ये था थोड़ा सा गलत लिख दिया मैंने, ऊपर वाले को जरा मिटाता हूँ. तो ऊपर वाला जो था 0, 0 to 15 था ना, इसको भी इधर से थोड़ा सा हटा देता हूँ. इसको अब ठीक है. So that will 0, 0, 0, 0, 0, 0 up to 0, 0, 0, 0, 1, 1, 1, 1. And this one is 16, which is 0, 0, 0, 0 to 0, 0, 0, 1 and 1, 1, 1, 1. You get 31. Then Malviya hostel 32 to 47, which is 0, 0, 32. So this is 1, 0 and 1, 2, 3, 4. And this is up to 0, 0, 1, 0, and then 1, 1, 1, 1. And Patel hostel is 48 to 63, which is 0, 0, 1 1 and 0 0, 2 0 0 1 1, and then 1 1 1 1, 63. So now you can see in any address, if I write address say 35, which is 0 0, and then what, 1 0, और 35 में क्या होगा, 0 0 1 1, 35 हो गया ये, 32 हुआ और 335. Okay, so if I want to see where this address is, so first 2 bit 0 0, that remains as it is. Now if you look over the next 2 bits, which is 1 0, next 2 bit 1 and 0. So if you go to the next 2 bits, these 2 bits, for Tandon hostel, first next 2 bits are 0 0. Hostel की 2 bit हैं ये. This is already in the for denoting the hostel, which are always 0 0. Now next 2 bits are 0 0. This means this is Tandon hostel. And if next 2 bits are 0 1, so this means this is Tandon hostel. Previous one was Tilak hostel. Okay, and next 2 bit, yeah, 0 0, and then next 2 bits are 1 0. If they are 1 0, then that means this is a Malviya hostel. And you can see here, these 2 bits are 1 0. So this address belongs to Malviya hostel. And if these 2 bits, that means third, fourth bit, if they are 1 1, this means the address belongs to, if they say something like 0 0 1 1 0 0 1 1. Okay, third address inside the Patel hostel. ये कितना हो गया, 32 और ये हो गया 48. 32 plus 16, 48 plus 3, तो ये 51 हो गया. So this means now 2 more bits has been taken and they are denoting a sub block inside the hostel. So hostel, first 2 bits are 0, and then next 2 bits, if they are 0 0, it's Tilak hostel. If they are 0 1, then this is Tandon hostel. And if it 1 1 1 0, then this is Malviya hostel. And if it 1 1, then it's Patel hostel. Okay. So now first 2 bits are denoting block, which is saying hostel, and the next 2 bits are denoting a sub block, which is a particular hostel inside. And then remaining 4 bits, these 4 bits are denoting node ID. Okay. So if you now go to the IP address, there are 3 portions now. First portion, which we are denoting a bigger block, which we are saying is known as network ID, net ID, which we are saying hostel hai ya main building hai ya computer center hai. So first 2 bits are denoting the network ID. And within one network, if we have divided into sub networks, then these 2 bits, they are denoting subnet ID. Okay. So there are 3 parts now inside our IP address. If you look into one portion which denotes network number, which we say net ID. Okay. In this case, first 2 bits are denoting net ID, and then next 2 bits, they are denoting subnet number, subnet ID. So we say that a network has been divided into sub blocks or subnet ID or subnetworks. Okay. So Tandon hostel, Patel hostel, ये subnet है. And now the 4 bits, these 4 bits, they denote node ID or node number. Okay. So this is how a IP address has been divided into different fields. Network number, which are obviously towards the most significant bit. Then subnet number. After network number, there can be subnet number. And if no subnet is present, then fine, network number and the node. But if some subnet is present, like inside a hostel, you have 4 different type of hostels with different names. Okay. So a subnet can be there and some bits can be dedicated to that subnet. And then in the last is node number. And please remember, this subnet can further divide into different subnets. Okay. So this subnet, ये subnet जो है, can further divide into different subnets. So अगर मैं आपसे कहूं जरा बनाइए क्या कि this Malviya hostel है आपका, and in Malviya hostel 2 wing बनाइए, wing number 1 and wing number 2, and tell me how many maximum address can be there in wing number 1 and wing number 2, and the range of addresses. बनाइए जरा, बताइए मुझको. That Malviya hostel में 2 wing बनाइए. Okay. So that is subnet के अंदर या सब ब्लॉक के अंदर फर्दर उसको स्मॉलर ब्लॉक में डिवाइड कर दिया है ना. अभी क्या किया था हमने, बनाइए उसको, मैं इतने ये बता रहा हूँ कि दिस वाज योर hostel, a bigger block, and then hostel was divided into 4 blocks, smaller blocks. 4 smaller blocks which were of same size. And then now I'm saying कि Malviya hostel अगर ये है मान लीजिए, तो इसको 2 wing बना दीजिए, एक wing number 1 और एक wing number 2. And let me know in wing number 1 and wing number 2 from which address to which address machine can hold those addresses. कितनी नोड हो सकती है. बनाया? क्यों भाई? बना? बनाइए बनाइए, किसी का बन जाए तो मुझे बताए.
सर 8.
So maximum addresses can be 8 because that hostel contains 16 addresses, so you divided it into 2, so it can be 8. और रेंज बताओ कहां से कहां तक है. विंग 1 की रेंज कितनी होगी?
0 to 7.
0 to 7, ये आईपी ये एड्रेस होगा 0 to 7। रेंज देखो, रेंज कितना था। मालवी हॉस्टल का एड्रेस रेंज क्या है?
सर 32 to 39 होगा।
32 to 47 है। हाँ, तो उसको
तो बिंग 1 का होगा 32 to 39।
32 टू, हाँ ये तो कितनी रेंज थी? मालवी हॉस्टल की रेंज थी 32 to 47, है ना? तो फर्स्ट 8 इधर गए विंग 1 में, तो 0 to 7 नहीं होगा। 32 to कितना, कहाँ तक पहुंचा भाई? 7
39
और दूसरा वाला हो गया 42
42 47।
47, ये 2 हो गए, है ना? और इसको भी अगर आप कन्वर्ट करिए तो मुझे बिट नंबर बताइए क्या रहेगा।
सर 30 to 39 का होगा सर
0 पहले हो गई, फिर दूसरा वैल्यू तो फिक्स हो गई थी ना, सेकंड 2 बिट क्या थी?
10।
102 हो गई। अब इसके बाद ये बिट थर्ड वाली बिट लेंगे हम, है ना? फिफ्थ वाली बिट लेंगे। सो फर्स्ट 2 बिट, देन नेक्स्ट 2 बिट, एंड देन फिफ्थ बिट इज 0। व्हेन दिस बिट इज 0, और रिमेनिंग तीनों बिट जो है वो कहां से कहां तक वेरी करेंगी? 0 0 0 to 1 1 1। ठीक है। सो दिस इज गोइंग टू बी, अगर फिफ्थ बिट 0 है दैट मीन्स इट इज विंग नंबर 1, राइट? ठीक है ना? और ये वाला सेकंड वाला देखिए, मालवी हॉस्टल 0 0, पहली 2 बिट 0 0, फिर मालविया हॉस्टल है सो 1 0, नेक्स्ट 2 बिट, एंड दिस विंग वैल्यू इज 1। तो ये आपका डिनोट कर रहा है मालविया हॉस्टल 2 बिट, ये डिनोट नहीं, ये डिनोट कर रहा है हॉस्टल, एंड दिस इज डिनोटिंग कि ये मालविया हॉस्टल है, एंड विद इन मालविया हॉस्टल दिस 1 इज डिनोटिंग कि ये विंग नंबर 2 है। द वैल्यू विल रिमेन 1, and then it will vary from जो नोड के एड्रेसेस हैं, that will vary from 0 0 0 to 1 1 1। ठीक है ना? 8 एड्रेसेस होंगे। एंड नाउ वन मोर थिंग, एक चीज और बता दूं, फिर मैं मैम को बुलाता हूँ उसको एक्सप्लेन करने के लिए, जो वो पीर टू पीर वाले में नेटिंग वाला। वन मोर थिंग, we do not use, जो ब्लॉक है, ब्लॉक का जो फर्स्ट एड्रेस है वो यूज नहीं करते। लाइक हॉस्टल है तो हॉस्टल का जो एड्रेस था 0 0 था, तो द एड्रेस 0 0 we do not use to assign to any node। एंड जो लास्ट एड्रेस है, सो लास्ट एड्रेस हॉस्टल का क्या था? हॉस्टल का फर्स्ट एड्रेस 0 था, लास्ट एड्रेस था 63 which was having 1 1 1 1 1 1। नहीं, पहली 2 बिट 0 और फिर 1 2 3 4 5 6 था 63। So we do not assign 63 to any node, and first address which was 0 to any node. These two are not assigned to any node. First address is used to denote that block. Like आपने कहा कि मालविया हॉस्टल है, तो मालविया हॉस्टल का पहला एड्रेस कितना हुआ? 32। मतलब आपका 32 को यूज नहीं करेंगे किसी भी मशीन को देने के लिए। ठीक, will not use to assign to any machine this address। और लास्ट एड्रेस हुआ 47, so मालविया हॉस्टल का, और हॉस्टल का हुआ 63, राइट? So 47 को किसी भी मशीन को असाइन नहीं करेंगे, will not assign to any machine। This is used as a broadcast address within that block। So last address जो block का है is used as broadcast address, and first address is used to identify that block। Now let me say that first address is used to identify the network number, तो नेटवर्क को आइडेंटिफाई करता है। ब्लॉक को मैं रिप्लेस कर दे रहा हूँ नेटवर्क से और सब ब्लॉक को सबनेट से। ओके, so first address is used to assign the network or to subnet, and the last address of that subnet or of that network is used for broadcasting within that network or within that subnet. Okay, so two addresses are not used to assign to any node. बाकी जितने बचे, so hostel है, hostel में 64 addresses हो सकते हैं -2, so 62 nodes can be assigned these addresses. Okay, तो ये था जो दो एड्रेस यूज नहीं होते। ये दो एड्रेस, एक तो आपको बताया मैंने कि ब्रॉडकास्ट के लिए यूज होगा, और जो पहला एड्रेस है उसको राउटिंग में यूज करेंगे। कैसे यूज करेंगे वो जब अगले लेक्चर में बताऊंगा। तो अब जरा मयंक को बुला दूं मैं, 1 मिनट होल्ड करिए, तो वो आपको ये समझा दे कि जो पूछ रहे थे ना पीर टू पीर वाले। मयंक होल्ड
आज से बता देता हूँ, पीयर टू पीयर पढ़ाऊंगा तो बता दूंगा बाद में। हेलो, am I audible? Am I audible?
Yes, sir.
Okay. So, Tyagi sir has suggested me to tell you something about how to traverse NAT when you are having a peer-to-peer connection. I'll be taking a full-blown lecture on peer-to-peer network, and then maybe for half an hour, 1 hour, I'll be able to explain you how actually peer-to-peer connection work across these NATs. Just for a brief thing, as Tyagi sir might have discussed, clear कर दीजिए, whiteboard नहीं use करते। So if you see in NAT, what is happening that when you make a request through NAT नहीं पता है, okay, कोई बात नहीं। So when you make a request, then this request is forwarded after changing the source IP address, right? So only egress requests are allowed through a NAT box. The person who is requesting from inside to outside, the entry is made and a provision is there so that this request can be forwarded to the public internet. Now, once this particular session has been formed or mapping has been done, only the replies can come on this mapping. But nobody can initiate an ingress through the NAT. That is the quality of NAT. So, as we know that in peer-to-peer, we have to have two nodes, which each of them can make connection to other. Suppose I take example that there is a NAT here in IIIT, and there is a NAT here at MNIT, and a node here, say P1, wants to have a connection with P2. So how this connection can be made? So this is allowed from inside to outside, but this connection has to come from outside to inside in IIIT NAT, which is not allowed. And vice versa from P2 to P1. So how to achieve this thing and how these things are achieved? There are specific protocols which are described in RFC, protocols known as STUN and protocols as TUN. I will be discussing this when I take the peer-to-peer lecture. So STUN is Session Traversal Utility for NAT, traversal using relay through NAT. So we have these STUN and TUN public servers, and generally they use the technique known as relaying. Because from inside to outside, it is allowed. So this node will make a request to a TUN server. And this node can also make a request to turn server. Now at this particular turn server, we can change the socket identifiers and blah, blah. And then this turn server can relay this request on this particular connection, which is already made between a node P2 and turn server. So this is just in brief, I can tell you. So there are two protocols which are utilized for, and this whole process is known as NAT traversal, hole punching. So there are two types of hole punching, UDP hole punching and TCP hole punching. That's a very detailed topic. And I'll take one lecture on this, don't worry about that. One more thing I want to tell you, there are variety of NATs. So it's not like only one type of NAT is there. So the NAT are full cone NAT, half cone NAT, there are address restricted NAT, port restricted NAT, symmetric NAT, there are variety of NAT. So first of all, you need to identify that application is behind which type of NAT, which is done by the Eastern server. Eastern identifies that which type of NAT a particular node is behind. And depending upon the NAT type, there are NAT traversal utilities which are utilized by this guy. So this is what this particular moment, because you what Tyagi sir has told me, you are not very much aware about NAT also. So we'll be seeing that. Okay. Anything if you want to ask, you can ask. Okay. Okay.
हाँ चलिए, तो कुछ थोड़ा बहुत आप लोग को वो पीर टू पीर वाले में कैसे भी होता है वो आ गया होगा कुछ मोटा मोटा. ओके, so where we were at okay, so as I was telling that there are 3 fields and the address which we are writing. So now when we write a particular address, we write something in this fashion. Like if for a node कितना लिखा था हम लोगों ने, मालवीय में अगर थर्ड एड्रेस है, मालवीय हॉस्पिटल अगर हम लेते हैं तो 35 लिखा था ना मैंने, 35, and that 35 was denoting like 00. then मालवीय था तो मालवीय के लिए कितना था, मालवीय के लिए 10 था, 00 then 10 and then 0011, third address which was 35. Okay, so now we used to write the address something like this. जब हम लोग denote करते हैं address को 35/x, where x is number of bits which are in network portion or subnet portion. Network portion or subnet portion. Okay, if subnet is present, then the total bits are written. Okay, so x is, this is the way the IP address is actually written. Generally, you will find like this. So 35/x. So that means out of this, if we write here 35/4, this means in 35, in this address, 4 bits are used in network and subnet. Okay, so we're writing this, something says 00100011/4. Okay, so this x value is 4, and that tells that there are 4 bits. Obviously, the first 4 bits which belongs to net ID plus subnet ID. Okay, it do not tell us how many bits are in subnet and how many bits are in net. Doesn't matter. It only tells that this portion is, and remaining portion is the node portion. So if node portion. Okay, so now we used to write IP address और आईपी एड्रेस को अब 8 बिट छोड़ दीजिए, अब हम लोग ने ले लिया उसको 32 बिट. Okay, let us come to now 32-bit IP address. As I said, it is written something like this: 202.141.55.6. Now you can understand that this address contains 4 fields. Each field is of 8 bit. 8 bit है हर एक में. तो अभी तक हमने खाली 8 लिए थे, अब 8 बिट के 4 फील्ड हैं 8 बिट. 8 bit and 8 bit. Okay. Now out of this, when we are writing this address, we specify something like this: 202.141.55.6/24. Now when we have put it /24, this indicates that there are first 24 bits which belongs to net ID. Okay, so first 24 bits belongs to net ID and remaining 8 bits belongs to host ID. So in this 24 bits कौन सी होंगी, यहाँ से लेके up to here. Okay, so these 24 bits, they are net number. This is the network number, and this belongs to host ID or node ID. Okay. So that's way we used to write IP address and different field. Net ID में network number भी हो सकता है और साथ में subnet number भी हो सकता है. Doesn't matter. And first address, like in this block, अगर ये वाला block ले आऊं तो इसमें 202.141.55.0 ये first address है, first address. और last address है 202.141.55255. This is the last address of this block. और first address ये है. So first address is the network address and it is not assigned to anybody. And last address is broadcast address. Broadcast address means if we use inside a packet this address, the packet will go to all the nodes which belongs to that network. Okay, that's a broadcast address. So these two addresses are not used. And in this, because there are 8 bits in the node ID. So total number of hosts which can be connected is 2 to the power 8 minus 2. 254 nodes which can be connected inside that network and can get different IP addresses. Okay. और इसको हम लोग बोलते हैं, जो हमने लिखा /24. This is the X value, the value of X /X. Okay. तो इतना हो गया. अगर इसमें किसी को कोई कंफ्यूजन हो तो बताए, फिर बाकी एक चीज है जिसे हम बोलते हैं नेट मास्क, वो अगले लेक्चर में शुरू बताऊंगा, नेक्स्ट लेक्चर में. अभी आप ये समझ लीजिए बस कि अगर कहीं पे कंफ्यूजन हो तो बताइए कि आईपी एड्रेस, उसके अलग अलग फील्ड एंड which blocks they denote. And as I told you that these fields are going to be used in routing. In routing, when we are trying to deliver a package to a particular network and then to a particular node within that network. So those fields are going to help in forwarding of the packet towards the destination. In forwarding algorithm, we will be seeing the use of these fields, which we are saying network number, subnet number. तो चलिए ठीक है, अगर किसी को कुछ पूछना हो तो बताएं, वरना फिर फिनिश करते हैं लेक्चर को। ओके, किसी का कोई क्वेश्चन हो तो बताएं, अगर नहीं है तो लेट अस फिनिश द लेक्चर। ठीक, फिर ओके, थैंक यू।
Thank you, sir.
अभी मैं बाहर जा रहा हूँ।